Hi guys, welcome to Apollo 1. In this video, we're going to talk about a number base and some conversions from one number base to another. So, what is a number base? A number base is a combination of digits which a system of counting uses to represent numbers. And by that, I mean that a number base tells us how many digits a counting system uses to represent numbers. For example, let's consider the most commonly used number base system. I'm talking about the decimal or the base 10 system. The decimal, also known as the base 10 system, uses 10 digits. Digits from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 to represent numbers. Numbers like 1, 23, 95, and so on. Just to mention, the base 10 is also called the place value system. It is also called the place value system because the numerical value of a number relies on the position of each digit. For example, let's consider the number 23. For the number 23, the digit 3 sits on the unit side, while the digit 2 sits on the tenth side. So, since 3 sits on the unit side, whenever we're talking about units, we have 1 unit. We have 1 unit, or we can also say that 1 unit is 10 raised to the power 0 because it's in base 10. So this is equivalent to 3 times 10 raised to the power 0 plus the 2 is on the 10th side, and the 10th side also means 10. We can say 1/10 or 10 raised to the power 1. So plus 2 times 10 raised to the power 1, which is equal to 3 plus 20, which will still give us back the number 23. As we can see, the numerical value of each digit makes up the number. Just like the base 10 system, we also have other number-based systems. Like we have the base 1 system, also known as the unary system. Then we have the base 2 system, also known as the binary system. The binary or the base 2 system uses just 2 digits, 0 and 1, to form numbers. Then we have the base 3 system, which uses digits 0 to 2 to form numbers. Then we have the base 4 system, which uses digits 0 to 3 to form numbers. Next, we have the base 5 system, which uses digits 0 to 4 to form numbers. Then we have the base 6 system, which uses digits 0 to 5 to form numbers. Next, we have the base 7 system, which uses digits 0 to 6 to form numbers. Then we have the base 8 system, also called the octal system, which uses digits 0 to 7 to form numbers. Then we have the base 9 system, which uses digits 0 to 8 to form numbers. Next, we have the base 10 system, which uses digits 0 to 9 to form numbers, as we have already talked about previously in the video. Then we also have the base 16 system, also known as the hexadecimal system. This system not only uses numbers, digits 0 to 9 to form numbers, but it also uses alphabets A, B, C, D, E, F to form numbers. And A represents 10, B represents the number 11, C represents the number 12, D represents the number 13, E represents the number 14, and F represents the number 15. I know that the hexadecimal system or the base 16 system may sound tricky, but we'll talk about it later on in the video. Now, let's talk about converting from base 10 to other bases. Let's convert the number 9 to base 2. Okay, let's use another color. Let's convert 9 to base 2. So to convert 9 to base 2, we'll just basically write the number and the base in this format, and then we divide. 9 divided by 2 will give us 4 remainder 1. 2 divided by 4 will give us 2 remainder 0. 2 divided by 2 will give us 1 remainder 0. 2 divided by 1 will give us 0 remainder 1. So to get our answer, we take our answer from bottom to top. We just draw an arrow like this, and we take our answer from bottom to top. So our answer becomes the number 9 is equivalent to 1001. 1001 in base 2. So this is our answer. Let's take another example. Let's convert the number 31 to base 3, base 8, and base 16. Let's try the first question. To convert the number 31 to base 3, we still carry out the same steps. We divide and collect the remainder. 31 divided by 3 is 10 remainder 1. 3 divided by 10 is 3 remainder 1. 3 divided by 3 is 1 remainder 0. 3 divided by 1 is 0 remainder 1. So again, taking our answers from bottom to top, The number 31 is equivalent to 1011 in base 3. So this is our answer. So to attempt the next two questions, please feel free to pause the video and attempt the examples, because the more examples you solve, the better you understand. Okay, let's solve them together. Let's convert 31 to base 8. Eight 31 divided by 8 is 3 remainder 7. 8 divided by 3 is 'Let's convert the number 31 to base 8. Still the same steps. 31 divided by 8 is 3 remainder 7. 3 divided by 8 is 0 remainder 3. So taking our answers from bottom to top, don't forget our number 31 is equivalent to 37 in base 8. Let's attempt the next question. The next question says we should convert the number 31 to base 16. So still the same steps, 16, 31. 31 divided by 16 will give us 1 remainder 15. 1 divided by 16 will give us 0 remainder 1. And I know some of you will be wondering, are we going to write 1, 1, 5 as our answer? No, we are not. Don't forget, base 16 or the hexadecimal system not only uses digits, but also uses the letters of the alphabet from A to F to represent numbers. A, B, C, D, E, F, where A represents the number 10, B represents 11, C represents 12, D represents 13, E represents 14, and F represents 15. So as we can see, the 15 here, we can replace it with the letter F as we see on our list. So our answer becomes the number 31 is equivalent to 1. Instead of writing 15, we write F instead in base 16. So this is our answer. Now we are going to look at converting numbers from other bases back to base 10. Let's convert the number 10101 in base 2 to base 10. For our first example, to convert 10101 to base 10, the first thing we do is to assign place values to the numbers. To assign place values to the numbers, we number the numbers backwards from 0. We give them numbers like exponents backwards from 0. So here becomes 0, 1, 2, 3, 4. So this is equal to, starting from the back, 1 times the base carries the power 2 raised to the power 0 plus 0 times 2 raised to the power 1 plus 1 times 2 raised to the power 2 plus 0 times 2 raised to the power 3 plus 1 times 2 raised to the power 4, which is equal to 1 times 2 raised to the power 0. We know that 2 raised to the power 0 is 1. So 1 times 1 is equivalent to 1 plus 0 times 2 raised to the power 1. 0 times anything is 0. So here becomes 0 plus 1 times 2 raised to the power 2. 2 raised to the power 2 is 4. So 1 times 4 is 4 plus 0 times 2 raised to the power 3. 0 times 2 raised to the power 3 is 0 plus 1 times 2 raised to the power 4. 2 raised to the power 4 is equal to 16. So 1 times 16 is 16. So our answer is equal to 1 plus 4, 5 plus 16, 21. So we have gotten our answer. Therefore, 1 0 1 0, okay, 1 in base 2 is equivalent to the number 21. So this is our answer. Let's take another example. Let's convert 2 1 2 in base 3 to base 10. Okay, the first thing we do is we assign place values to the numbers. We number 0 1 2. So this will be equal to 2 times 3 raised to the power 0. Don't forget, we are now operating in base 3. That is why it's 3 raised to the power 0 plus 1 times 3 raised to the power 1 plus 2 times 3 raised to the power 2. This is equal to 3 raised to the power 0 is 1. So 2 times 1 is 2 plus 1 times 3 raised to the power 1, which is 3 plus 2 times 3 raised to the power 2. 3 times 3 raised to the power 2 is 9. So 2 times 9 is 18. So our answer is equal to 2 plus 3, 5 plus 18 equals to 23. So therefore, 2 1 2 in base 3 is equivalent to the number 23. Here is our answer. Okay, let's take another example. Why don't you try this one yourself? Convert 2D in base 16 to base 10. Again, please feel free to pause the video and attempt the question, because the more questions you solve, the better you understand. Okay, let's attempt the question together. Let's convert 2D in base 16 to base 10. So the first thing we do is we assign values. The D has the power of 0 and the 2 has the power of 1. This will be equal to D times 16 raised to the power 0 plus 2 times 16 raised to the power 1. And I know some of you will be asking what the D is meant to be doing where it is. Well, as I've said previously, the base 16 also uses alphabets to represent numbers. Alphabets like A, B, C, D, E, F, where A represents the number 10, B represents 11, C represents 12, D represents 13, E represents 14, and F represents 15. So as we can see, D represents 13. So we'll replace the alphabet D with the number 13. So this will be equal to 13 times 16 raised to the power 0 plus 2 times 16 raised to the power 1, which is equal to 13 times 16 raised to the power 0, right? 16 raised to the power 0 is 1, so 13 times 1 is 13 plus 2 times 16 raised to the power 1. 2 times 16 is 32. So our answer is 13 plus 32, which is equal to 45. So therefore, 2D in base 16 is equivalent to the number 45. Okay, that's all for the video. Please feel free to subscribe and support this channel.